Yeah. So as I've told you, this branch of geodesy is offering a wide range of specialties. And initially, our job was to prepare the maps, and in that preparing the maps was only not for only the cities or for a country, and it has to be done for variety of major applications. That's why this engineering geodesy word is very popular, where we are very much into the details of how uh, different types of steps needs to be performed to give a map or as a final deliverable. Then obviously this engineering geodesy is the classical surveying. Then obviously the satellite geodesy with our majority of the thrust which is going into the so-called determination of variety of parameters with the help of uh, you know mechanism by which we are monitoring our earth, be it VLBI, be it SLR, LLR, etc. Then there is this very popular word, it's called earth observation. Nowadays if you see, man, variety of so-called programs, internship offers, in fact the short-term courses by variety of universities around the globe, they are offering these kind of courses on earth observation. So EO4, so there is a short acronym which we are using, EO, and then the numeric 4 for land application, for hazard monitoring, for uh, the so-called pattern recognition. So I mean, they are just using this first acronym EO4 for everything, whatever you have. So this observation of Earth's gravitational field, determination of the orbit is also one of the prime responsibilities. Then the remote sensing, obviously, the observation and measurement of Earth by means of optical sensors, Geo-Informatics, the digital processing of the data relating to the position in geographic space, the navigation, the routing, the precision agriculture. So these are these kind of applications are coming out of your parent branch of geodesy. Then obviously the geoinformatics is one of it. Okay, but it is not possible to just separate it out and just say we do not know what is geodesy. It is not possible. Okay, you have to understand the basics of geodesy. Then only you will feel comfortable in managing or I would rather say in understanding the coming future of geoinformatics. Okay. So, but before going into the details of geodesy, just I would quickly ask one by one. We'll starting with Alok. Alok, what have you learned in those 6 lectures? Can you just explain it? You can also share your screen if you have any content. Alok Kumar, I guess the name. Yeah. Alok, you are not audible. Are you speaking something?
Yes, sir. Hello.
हाँ, बताएं. What have you learned in those 6 videos? Can you explain it one by one?
Yes, sir. Hello.
Yes.
Yes, sir.
Yes, you are audible. Go ahead. Hmm.
Okay. Sir, in first lecture, we learned about surveying and engineering surveying.
Do you have anything to share as a screen that would be more comfortable with the others?
No, sir, I have made notes on my notepad.
Oh,
Handwritten
okay,
notes, sir.
okay. Now it's time to avoid those handwritten kind of thing. This is not your 11th or 10th level kind of studies. You just use your PC to have your Word file with your PPT file that you should prepare. I don't prefer these hand notes, okay? Except you have to do some mathematics kind of part of work where you have to write too many equations in a one go, and then you could
Okay,
prefer
sir.
it, but otherwise you have to just use your Word file. Okay, do in laboratory at least do not use the hand notes. Okay, that's how you will develop your skills to write technical mathematics. Okay, technical content. Otherwise, every time you would write on your end notes, that would not be, I mean, advisable. Okay. Anyway, go ahead.
Okay, sir.
Just little bit loud. I mean, if you could go ahead with lecture wise, that would also be good, so that others would follow. Like you, if you could start with in lecture one, I just saw this, and like that.
Okay, sir. Sir, in first module, lecture 1. Hello.
Yes.
Okay.
Yeah,
Sir, in first
I'm
module,
just listening.
Sir, in first module, in lecture 1, we have a study about what is geoinformatics and how it is measured and management, its management.
Okay.
And in second,
So what do you
module,
mean by geoinformatics? Can you explain it? What do you mean by geoinformatics?
sir, it is measurement of uh, it
Go
is a
ahead. Go ahead. Speak.
it is measurement of geographic features of
Mm-hmm.
geographic phenomena of world, near world. And
Mm. बोलिए बोलिए कंटिन्यू रहिए. आपकी आवाज नहीं आ रही आलोक. चलिए नेक्स्ट, जब तक ये ज्वाइन करेंगे, अभिजीत यू कैन टेक ओवर.
So, what you have taught, we have to discuss.
What you have listened to in those videos of module 1 and module 2. Okay.
So, your videos, na?
Not my videos, yeah. I have just given those link na NPTEL videos.
Yes, sir. I was also not aware of the video lecture. I thought the 6 lecture I was talking about the last year class.
Sorry, say again.
So I was also not aware about the some modules you are talking about now. I thought the modules are regarding the last 3 classes. So I not
No.
know about.
This is not your GDP course. This is your
Yes, sir.
laboratory. This is different from your content. Okay.
Yes, sir. So I was not able to read the modules.
Why?
No, I was not know that so there is need to learn module. I was not aware about that.
Why?
Uh,
Is it properly not posted on your teams?
yes, it. So you told about to read the last 6 lectures. So I assumed that it was last lectures you told.
Anyways,
it,
Abhijit,
it,
you
it
can
was a mis.
start it
It
now.
was.
Yes, sir.
Hmm.
Sir, I
You can
haven't
start.
watched that module.
भाई ऐसे आप लोग करेंगे तो कैसे काम चलेगा?
No, sir, I thought you have told, you have said what you have taught, you have to say.
Alok, you joined?
yes, sir. Hello.
Yes. Now you can start. Alok, you are not audible. Okay, we have, I guess, the sincerity level of MTech students is not up to the mark. We can move ahead with the PhD students. So, Parul, you can start now.
Okay, sir. So first of all, I want to. So first of all, what is geoinformatics? As sir told, it is an interdisciplinary branch of science and technology, which deals with the problem of uh, uh, physical phenomena on earth, like which deals with the problem of geography, geoscience, and it also involves cartography and many branch of science and engineering. So in the module, the we learned about basic concept of surveying. So first sir told us about what is surveying. So it is a collection of data and information. So the question arises, why we need surveying? So in our engineering project, we need surveying, and for surveying. So if you want to build a house, so what we for building a house, we need some information, like the first is we should have a knowledge of the topography, site selection, and we should plan a building on map. So all these need a surveying. So like for example, in town planning, dam construction, bridge planning, all these involves surveying. So what is surveying? It is a physical measurement of geo information. So if we divide word geo information, geo means earth, and information is something which is relevant or related to earth. So surveying is the physical measurement of geo information. So it is an art and science of obtaining and quantified measurement, and the interpretation of these measurement into a meaningful representation. So uh, so uh, huh. So then he told us about the measurement. Measurement of it is divided into two categories: surveying. The first one is surveying, and second is laying out. Laying out means taking the work into the ground as per design specification. Then he talked about a reference. When we deal with any measurement, we always consider a reference. Reference is also known as a datum, and datum. Then what is map? Map is the representation of the ground, and map.
Yeah, Parul, please again, once again, on the requirement of the datum, just like you mentioned. Just repeat it once again.
Okay, so okay, so okay, huh. So in surveying, we are talking about measurement, and when we perform the measurement, we need a reference system. So without a reference system, we can't measure anything. So in the lecture, sir told us if someone want to tell the height of a child, then he was indicating that the child is this much this much tall. So with respect to what, we should always consider datum reference point for measuring or surveying with respect to what we are dealing. So then then he talk about geoid. So map, and map is a representation of the ground, and map is a geometric representation. So as we all know that our topography is not like equal or similar everywhere. We have diverse topography, so we always need a plane or a reference point from where we can measure or we can perform our surveying. So the term geoid comes. So what is geoid? Geoid is a equipotential surface. So by the word equipotential means everywhere in the surface potential is same, means the gravitation is same, the gravity is in every point the gravity is same. So physical so geoid is a physical surface having the property where gravity at each point is same. So in the earth where we see this equipotential surface, if we look, the water surface water surface is a natural surface and it is equipotential. Then he talk about mean sea level. So what is mean sea level? The average surface of the sea. So in when we talk about geoid, the mean sea level represent the geoid. Then each feature uh, when we talk about surveying, we always consider a reference or datum, and in datum we come to know about geoid, and mean sea level is our geoid because the average surface of the sea represent the geoid. Then in lecture 2 he talked.
Yes, just stay. Yeah, yeah, yeah. Please stop. So
Okay.
what is really happening is that initially the emphasis is given on the need of datum. Okay, so it was highlighted that what is the need of the datum. Then obviously the datum cannot be only a single entity. It has to be divided into two part, which one is called as horizontal datum and another is called vertical datum. Now in the vertical datum, we are mainly interested in terms of heights around the country, around the globe, how the heights are distributed. But there is a challenge. The challenge is simple, that the continents are joined with the help of sea. You do not have luxury to move from one continent to other just like that. You have to cross that part of the water body. Okay, that is we call it sea. And second is called horizontal datum, which we try to define the two-dimensional coordinates of a particular point. So this was the essential emphasis that we need to first look on what is happening. The map is nothing a point, the coordinates joined to a particular point, is it? And then coordinates could be 2D, could be 3D. Okay, and in that coordinate part we have to also understand what is this x, y, and z. What is this lambda, phi, and h? We need to understand that part. So in two-dimensional, generally the lambda phi, the x, y, the north and east, these are the very popular terminology that around the globe people are using. Latitude, longitude, northeasting, the x and y, the Cartesian coordinates. And when we talk about the data in the vertical, that means we are talking about the heights. Why it is essential to understand the elevation difference to see how the topography varies from one side to the other side. That's just like in India, if you see, if you're coming from the coastal regions, you have to climb up towards the Himalayan zone. So how the topography is varying, you are just looking by your eyes, but in order to represent
Excuse me,
has
sir.
to be certain way you have to present a very popular term which you people can find in written in terms of just hello.
Sir, voice is breaking.
So we were talking about the so-called vertical datums to represent the height. So when we are representing the height, it has to be uh, defined by some datum. Okay, when you do not have datum, what will happen? The height in north zone would be different from the south zone. So you have to have a single datum for that. Datum has been defined by variety of means. Okay, but what is the mean? what is most important, what is the most important in terms of understanding the datum is how it is very good to say that we would consider of a plane region to be our zero height plane, and then we'll move towards every direction for height measurement. But what is the physical challenge that would be coming is to how to maintain the height of that plane area. So there are a lot of other challenges associated with the understanding the height system that is very much popular because variety of applications are related with this height value. See, the flow of water that has to be defined by elevation only. Okay, whether wherever your xy coordinate do not play any role in it. So that was the reason that uh, there one example which Parul was mentioning about mean sea level. Yes, it was one such datum, but this is just a realization. What we need actually is a different thing. So datum definition could be anything, how we want to define the datum, but the important point is how do we realize it. Okay, so it is just like in our imagination, we too much have thinking for a particular content, but how do you realize that content is obviously challenging. So that is one part. So definition of your reference or datum is important. Then second important thing, that once definition is finalized, you have to have certain ways to realize that definition. Okay. Previously we wanted that we want to have such kind of processor which should be very fast, but only after these Shilika chips the people are now getting these fast computer. This is the how we have realized our imagination. Okay, so similarly in our domain we can define as many as things possible, but we have to realize it, and in order to realize those definitions we have to attempt something. Okay, so that is one part. So we the focus is on the datum part. Without datum your map is useless, it is a waste of paper. Okay, so it has to have certain datum. Datum could be local, it could be global, okay, or it could be regional. So that is how our I mean, we were although we were ruled by Britishers, but Britishers were very good geodesists, they were very excellent surveyors, and that has our they our ancestors have inherited from them how to survey these kind of mountainous terrains, coastal terrains, and that is the beauty that Survey of India has diligently performed over last 2 centuries. So focus is on the datum part that we will discuss separately as part of your discussion. Yes, continue, Parul.
Sir, then in lecture second, the lecture second started. Then he again tell about the reference. It is a
Your voice is a little low. Please be a little loud. Okay.
okay. So again in lecture second, the lecture second start with the definition of reference. Reference is a mathematically defined system, and the reference is very important in geoinformation. Then the question arises: why we can't use Earth surface as a reference? So the answer is Earth surface is not defined. We do not know the characteristic of the Earth surface. So we can't put the Earth surface characteristic in the equation. So that is why we need the reference point. So the concept equipotential surface, what is it? It is perpendicular to the direction of the gravity, and the surface is also called as leveled surface or geoid. Then uh, how we can use the geoid in measuring the height? We can use the geoid in measuring the elevation, and the position of x and y are considered like if we consider the earth, then the best fitted shape is ellipsoid. So if we put a sir, if we put a position x and y on the ellipsoid, then we know the ellipsoid equation. Then we know the x and y. So now the principle of surveying. So there are some so so how we do surveying. There are many many ways we can do to to perform surveying. The first tape chain and other thing. Then the two maze. Then he talk about three principle of surveying. The first is whole to part. So in whole to part, what we do, if we consider the site, we can't consider the full site in the first instant. We divide and then perform our survey. So why we don't consider a site as a whole? Because to maintain the accuracy of the surveying, we should consider a site as should divide in the parts. So the concept here is whole to parts. Then second, he talk about control network. So what is control network? Something which control your area. So in this concept, he talk about the triangulation method. Like if we have a area and we divide the area into a triangle, and then we perform surveying. So it is it also be like it is it is more accurate, and it also like then then the third point is reconnaissance means to take an idea of an area. So what we do, if we select a site, the first thing a planner do or a surveyor do, we go there and write the area. What are the topography, climatic feature, what are the features are there in the area. Then there is
Okay, wait a minute. So another concept which is coming as whole to part. So in the case of whole to part, the initial objective of this was to avoid the errors. Now consider your the Indian map. Now I'm just asking one question. My first question is, which was the initial point? Are you aware of this part from where the so-called mapping of India was started? What was the initial point from where the instrument was placed initially? Are you aware of it?
So you're talking about the
South India.
reference site that is a gateway of India at Bombay.
So one answer is coming as gateway of India. Another one?
I think it was Indira
There's
Point.
one.
Indira Point, in Kanyakumari.
Indira Point. और बताइए. Anyone else? See, the objective was to choose an initial point and then take the first observation, or you could call it as a first bearing to a second point. Then we'll start the observation. So it was not the gateway of India, not the
That's
Indira
Chennai.
Point. Instead, it is Kalyanpur in Madhya Pradesh. Now you could imagine that Madhya Pradesh comes nearly into the center of our country. What is the possible reason that could be selection of this particular site as the initial point? Any wild guesses?
Near the center of India.
No.
Sir, average datum.
No.
Sir,
See,
topic of
as a
cancer and topic of
no, not really. See, the major region of selecting a point in middle of the country is that because a group of surveyor has to move in 4 direction, isn't it? And finally this map of whole country has to be combined, isn't it? So if they will start from here, they will have to move in like that. And if let's say they will start from here, they will move from here. If they start from bottom, they will move like that. So in doing so, and obviously the from northeast also they could start. So in any other manner, what will happen, the error vector would be more large. And after understanding the error propagation in GDP course, you would understand that error will be propagated from this point. If there is errors of let's say 2 meter, it would be propagated towards Kashmir if a point in Kanyakumari would be taken. So it, in order to avoid that huge error vector from one side to other, the point in middle is chosen, so that if error is introduced, an error would be there in measurements. There is no possibility that error could be avoided. Error would be there, but what will happen? The magnitude of vector would be nearly equal in farthest point all possible. So that's why the Kalyanpur was chosen as the first point, and it's another supporting reason was is that it is a fairly plain region with nearly bare minimum topography is available. And the Suranthal, there is another place where first bearing was taken. Okay, so Suranthal and Kalyanpur are the two regions. And what was the major concept is to avoid the errors, the minimum possible region to avoid the error, the large part of the error. Gradually we'll see the maps in any country are built from a triangulation network, and in that triangulation network you are measuring the distances, and then you are finally finding out the coordinates. So with the help of these, you will start from that coordinate that has been found out by the linear measurement which has errors. The error would automatically propagate to the coordinate, and then again you will start from here with another error. So that is one thing which was there to avoid the errors. And therefore the concept of whole to part was sincerely avoided thereafter in any kind of project, where in case you have to prepare the map of a, let's say, a big parcel of the land. Okay, then you would first choose the outer boundaries, and you would try to identify the control points where you would place your stations, and you would adjust your outer network first, so that when your outer network is adjusted, that is we call it traverse. So if your outer traverse is adjusted, obviously the error will be less propagated towards inside the map. So that's why the concept of whole to part was adopted. And then it has been it is a practice with the nowadays to develop or start any map. So first the control points are defined, the network is adjusted to, or we call it traverse is adjusted, and there are a lot of mechanism to adjust the traverse. And we will discuss one such method in our GDP course. But once the traverse is adjusted, now you can place your instrument and you collect the data for buildings, trees, natural assets, electrical assets, whatever you have as your priorities, you can prepare it. Okay. Yes, carry on, Parul.
Okay. Then he talk about a scale. Then scale is what? Scale is the representation of conversion of large area on ground into a paper. Then we have a different kind of scale. The first is representative fraction, that is RF. So in RF, what we do, 1 unit on map represent n unit on ground. For example, we say 1 is to 1000, which means like 1 centimeter in map represent 1000 centimeter on ground. Then there is engineer scale. Engineer scale is simply the representation 1 centimeter is equals to 50 meters. Graphical scale. Graphical scale is the graphical representation of the scale. So then there are two type of scale basically. The scale amount of the type of scale is based on the amount of information. The first one is a small scale, and the second is large scale. If we say 1 is to 100, so and then 1 is in 1 is to 100 is the large scale, and it gives the detailed information of the region. And when we talk 1 is to 1 lakh or 10 lakhs, it gives uh, less information but covers a larger area. Then uh, classification of survey, it is of two type: plain and geodetic. Then
Yes. One. Just wait for a moment. See, that is why the reason I wanted that you should follow the videos, which you haven't. The reason is simple. See, there are a lot of examples which are given in those lectures which are very good. We cannot be repeated every time. Okay. So what is really happening? You have to perform the uh, survey for mapping the data. Okay, for mapping purpose. In that particular case, what is important is you either work in a plain manner or where you consider your earth surface as a planar. Okay, and in second one it is geodetic survey where you do not consider your earth your surface as a planar, instead is a curved in nature. Okay, so these are the two different characteristics by which we try to adopt it. In fact, if you discuss the geodetic surveys, the geodetic surveys are of this nature. They are global in nature, they are regional in nature, and then finally they are local in nature. So finally, in global and regional scale, we fairly use the curved nature of Earth as our understanding. That's why the triangles that formed in the case of regional and local, regional and global surveys, they are not plain triangles; they are spherical triangles because they follow the curve of Earth. Okay, and in fact, you could see the figures where you will see that in the plain nature of the Earth, or where you consider Earth as a planar for your local work, like let's say you work in your city maybe. So in that domain you try to understand that you take the assumption that Earth is a planar rather than a curved body, and then the plane triangles were formed. But in geodetic nature you try to consider the Earth as a curvature. Second is the geodetic surveys are of the highest precision, that you lose around 1 mm in 100 kilometers. That kind of precision is required in measuring the distances. That means you would measure the distance of 100 meter, and then it is a possibility that you will lose 1 mm, or you contribute such kind of error. This kind of precision is required when you work with the geodetic survey. So that is the difference between planar and that's why the coordinate systems are also described in a similar fashion. We when we work in the case of plane surveying, we have to consider the state plane coordinate system where we do not have any kind of curvature into picture. But when we work with the geodetic survey, we cannot consider the state plane coordinate system. Instead, we have to work with a particular datum and associated map projection. Okay, that will project our 3D representation into 2D representation. Okay, that we will discuss in details. Yes, move. You can continue.
so plane surveying, it is a process of surveying by assuming that Earth is flat. So and in geometric surveying, is the process of surveying by considering the curvature and spherical shape of the Earth. Then okay, so then we come to lecture 3. Then sir talk about error and types of error. So first is measurement. So as we already know, all measurement contain error, and there is a no measurement is exact in nature. So we always need to adjust our data. Why we need to adjust our data? Because if we we do not adjust our data, there will be a chain of error, and ultimately when we put all in our mathematical model, then the whole mathematical model become wrong. So that is the main reason we need to adjust our data, sorry, measurement. Then so then he talked about error, types of error. Then where it is? So sources of error in measurement. There are three types of sources of error. The first is natural, like for example temperature, wind. These are the natural sources of error. Then second is the instrumental error. The instrumental the error caused by instrument measurement is known as instrument error. And the third is the personal error, like the person taking the taking the measurement introduce some error. This kind of error is known as personal error. Then he tell about classification of error. The first is blunder or mistake. So uh, it this type of error occurs because of the carelessness of the person who took the who take a measurement. Then second is systematic error. It is as the name suggests, it is caused due to systematic forces. These error follow some physical law. For example, temperature, gravity. And the systematic type of error can also be right into the mathematical model. And these type of error can be eliminated. Then the third is the random error. These error caused by many
These you can skip right now because
okay.
this is already been covered. Okay.
Okay.
If anything new is there that you have read or
Yes, sir.
listened, you can explain it. Otherwise, you can skip
Okay.
the error distribution part.
Then he talk about the precision and accuracy, and then true error and relative error. They yes, sir. Sir, in precision means the closeness of the observation. If the systematic error are eliminated, the precision of the observation became an indicator of the accuracy. And accuracy is the closeness of observation to be to the true value. Accuracy tell us the closeness of our observation to the true value. Then, sir, uh, repeat it, sir. You already tell us in the first lecture.
हाँ, हाँ, हाँ. आगे
सर आगे एक मिनट सर.
कितने
सर
लेक्चर तक हुआ ये?
सर ये थर्ड हो गया. फिर उन्होंने प्रॉपर्टीज बताया. हाँ, डिस्क्रीट आरवी, कंटिन्यूअस आरवी. हाँ,
ये तो सब तो हो
प्रॉपर्टी.
चुका है.
ये सर वही सब था. फिर
हाँ.
नॉर्मल डिस्ट्रीब्यूशन का.
Yes, then after
Then
I was just looking for the plotting accuracy. Has it been explained or not?
sir,
Must
probability
have been explained somewhere. Plotting accuracy.
plotting accuracy.
No, sir, that was not there,
No,
sir.
sir. No, sir.
ऐसा हो नहीं सकता है.
सर मैंने जहाँ तक किया उसमें तो सर प्रोबेबिलिटी उन्होंने बताया. और सर स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन टेबल यही सब था.
वो सब तो हम बता चुके हैं. There is one concept of plotting accuracy. उसको देखिए किस जगह बताया गया, उसको एक्सप्लेन करिए.
Sir, it was explained in the module 2, lecture 2.
हाँ, बताइए, एक्सप्लेन करिए. आप ही बताइए, यशोवर्धन जी आप बताइए. पढ़ा है आपने तो बताइए.
Yes, sir. So it was mentioned that the smallest point that can be plotted is 0.25 mm.
Yeah, please speak for a little loud.
Yes, sir.
See, as part of your MTech program, it is your I mean duty as well as your responsibility to improve your communication skills also. Okay, so the moment you speak, it should be well, loud and clear. until unless there is some problem with the audio and video, etc. But you have to consider this as your responsibility. We will not teach you how to speak and how to behave, but this consider your PG student, MTech student. You have to improve your communication skills both in terms of teaching and in terms of speaking as well as writing. For writing part, we will do something. We'll give you certain assignment or term papers which you have to present, by which your technical writing skills could be improved. But for speaking, you have to little put in your efforts also. Yes, Yashovardhan, go ahead.
Yes, sir. So it was discussed that minimum point which can be plotted is 0.25 mm. The, there is a scale of 1 by n. It means one unit of map equal to n units of ground. Then there was example given that if we want to if we use a scale of 1 by 100, then the area then it can be represented then the actual distance can be represented as 0.25 mm into 100. So any point which is less than 0.25 mm into n cannot be plotted. Then there was discussion regarding scale will be decided based on size of the area and significance of work.
So
If
see the plotting accuracy. Yeah, just wait for a minute. See the plotting accuracy. The need of plotting accuracy is that you have a choice of application. Let's say you have to perform certain work. Okay, let's say you are working on the something on roads. So roads cannot be visible on a national scale level map, isn't it? You have to work on road where you have to see the height, the width of a road to properly work with. So you have to choose the appropriate scale, and that would be given if you have this understanding that what a dot represent in a map. So if a dot is representing 20 meters, then 20 meters, there are a lot of things that would be covered in 20 meters. If a dot is representing 10 meters, then there are a lot of things that could not be performed. Certain tasks could not be performed in that 10-meter kind of window. So this plotting accuracy defines your understanding that how you are choosing a scale map, be it a small scale map or large scale map. So just a 1:1,000. I'm just asking one question. Yashovardhan, बताइए 1:1,000 and 1:20,000, which is a large scale map?
so 1:1,000.
Why?
So it will give the information of small area in great detail.
Yes, very good, very good. So small scale map will hide out the details, more detailing. The moment you say I want more detailed map, you have to go for large scale map. Okay, where your choice of attributes in terms of their priority should be highlighted. Okay, आप किन चीजों को highlight करना चाहते हैं, that should be properly given. Okay, so this is very important, that plotting accuracy should be you should be very much careful about that what kind of application you are choosing. For a variety of applications are there, and you have to choose the plotting accuracy very carefully. Okay, yes. Anyone which has covered apart from that standard normal distribution, etc., or normal distribution? Yeah, there is one more question which I want that you people should revert back. Parul once mentioned that the precision and accuracy. That precision is closeness among observation, and accuracy is closeness towards true value. But true value is not known. So how the accuracy would be defined?
गुड आफ्टरनून सर। सर अगर हमें एक्यूरेसी की बात करें तो सर हम यूनिट का यूज़ कर सकते हैं, क्योंकि सर अगर हम किसी मेजरमेंट को अगर सेंटीमीटर में है तो उसको मेजर करते हैं और एमएम में किसी को मेजर करते हैं, सर एमएम में एरर कम आएगी एज कम्पेयर टू सेंटीमीटर्स में।
mm centimeter will only come after you have a measurement. What I am
Yes, sir.
asking is, how do you define whether a measurement is accurate or not? Since you do not know the true value, the definition cannot be justified. So you have to reach out to something. Then only you will define whether my observations are accurate or not. Anyone else?
Sir, accuracy is defined as the closeness with the true value. But if we perform our experiment with the great precision, then we can reach up to certain level to the true value. The more we get precise, the more we get accurate about the true value.
It is not possible. It is not possible at all. This is the this is the confusion, I would say. I would not say the silly mistakes that people are committing. This is the confusion among many people, that if you take the precision towards higher level, accuracy would be achieved. Not possible. Not at all possible. If your instrument is giving deviated measurements and you are not aware of it, you will never achieve an accurate observation. It will be highly precise, because every time you are getting the observation, it is close to the previous one, but it is not close to true value. So the more you choose the precision, it doesn't justify that every time you will achieve the accurate one.
Sir, the concept of most probable value MPV can. So, sir, if we don't know the true value, so we consider the maximum likelihood value nearest to the true value. So, so sir, this can resolve our problem.
Yeah, that is what I was interested in listening, that since you do not have the estimate, you do not have the understanding about the true value, but you have the most probable value with you. Okay, so the accuracy would be defined how your observation is near to the most probable value, or the any estimate of the true value, rather than the closeness with any arbitrary value. So you have to be very careful that the mean or the most probable value is given to you or not. If it is not, then you have to devise or first achieve the most probable value, then only you will comment on the accurate one. From we'll discuss in detail about this precision and accuracy in our GDP course once we reach there. Still we are in middle way of doing those kind of statements, but we'll discuss in details about with examples that why precision and accuracy are defined separately. And in fact, this is our blunder that we commit. Sometimes we use word precise and sometimes we use word accurate interchangeably without knowing their meaning in our statements, which just Sumit has just did. I mean, uh, unknowingly he has said this, but in fact this is true. Many of our technical experts, they commit such errors. That precision and accuracy, all measurements, they could be precise, they could be accurate, but the definition is different. Okay. Anything else? Any more information, Parul, on the lectures?
Sir, then residual, he talk about residual also. If we residual is most probable value minus the observation, so we get the residual.
That we have explained. Anything more than that, I was just asking.
No, sir.
What we have covered in the GDP, anything more than that?
No, sir.
Okay, okay. So we have other PhD students. Sudhir, you are also there.
Good afternoon, sir. Hello. Hello. Sir, are you getting my voice, sir? Hello. 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 Excuse me, sir. Hello. Sir, thank you for sharing this modules and lecture. Those are very, very good and basics covered. I have gone through up to the fourth one, and I have gone through the basic concept of surveying, and I have understand about the geoid, ellipsoid, and then in the second lecture about the surveying, if we are going to map anything before that one, we had to go for different kind of survey, like reconnaissance survey, and then we have to fit the control network. After fitting the control network, we can go for this different kind of survey and identifying the trees and all and other objects. And then he told about the scale, that he different kind of scale, like representative fraction scale, engineering scale, and graphical scales. So those are the things, sir. Then lecture third, he told about the error of the measurements. In this one, sir, he told about the sources of errors, like natural errors, instrumental errors, and the personal error. And then he told about the classification of the errors, like first is the blunder mistakes, second is the systematic error, which can be done because of the gravity and all. Then third is the random error, sir. That random error we cannot account for, means it will be there, sir. We cannot totally remove these random errors. Then he told about the precision and accuracy. What is the difference between the accuracy and precision? Then he told about the that most probable value. Suppose we do not get the true value, then we have to get the most probable value. That is the maximum likelihood to be nearest to the true value. That will be used for the checking the accuracy and precision. And then he told about the random error distribution. These are new for me, but I have gone through, sir. These are very nicely explained, like use of normal distribution, standard normal curve. And then he also told about the in lecture 5, sir, he told about the use of standard normal curve and the outliers, sir. Sir, this I have covered up to this, sir.
Okay. Okay, good. So anyone else who have gone through those videos, except those who have not seen those videos yet? From MTech students?
Sir, whatever ma'am has already told, that we have to repeat also.
No. Just I wanted to ask those who have covered
Anything
it.
new?
Those who have listened it actually. Yeah, anything new?
No, sir, that is being told everything.
Shivam.
Ji sir.
Have you gone through those videos?
Yeah sir, but only 3 modules. Oh, sorry, 3 lectures, sir.
Why?
Sir, fourth one is not.
Sunil.
Yes, sir.
बताइए.
72 lecture watch.
ऐसे चलेगा नहीं काम.
सॉरी सर, अभी कल
ये उसको.
मुझे सही सर, अभी कल आपने बताया उसके बाद मुझे लिंक मिला तो 2 लेक्चर ही हो पाया.
Anyways, okay. That's fine. So, what we will cover, see, because in these videos you came to know about the importance of the datum, and obviously about the specifically about the vertical datum, the importance of vertical datum. In fact, you have seen one example of mean sea level, so that is important that you should be aware of these things. But we will discuss this part in detail. Okay, and that aspect is covered actually in the geometrical geodesy, where we try to find out with the help of geometry of points, can we say something about Earth. So whenever we talk about the so-called horizontal datum, it consists of certain points. When we talk about the vertical datum, it also consists of points. So basically, you realize those datums with the help of set of points or a group of points. So that is one thing. But ultimately, our main objective is to learn in detail about the background of those datums apart from the coordinate system. So one thing is the datum, where you discuss about the horizontal as well as vertical one, but later on you will see that when we talk about the horizontal datum, this is nothing but a coordinate system. We are talking about the coordinates, how to represent a coordinate. See, because latitude, the moment you explore on Google Earth, let's say, okay, so on Google Earth, what will happen? You sometimes see that on bottom it is written as some lat long, and then there is a value in meters. Can anyone know what what does that represent? That represent the lat long of a particular area where your cursor is. But what is the height that is written just alongside with that? Are you aware of that? Which height is that? How many of you have seen or worked with Google Earth? Because it is a very popular software nowadays. And in fact, in the past 10 years, people have utilized it very well. Are you aware of those the heights which is mentioned? Can you explain it? Which height is that?
Sir,
Arun, are you
sir,
aware of it?
sir, I used Google Earth in Google Earth, but sir, I think mean sea level height or elevation they are showing.
No, it is not the mean sea level height. Google Earth is not for India, is it? No, it is for whole the complete continents, complete globe, isn't it? So the height which is mentioned in that uh, Google Google Earth image is ellipsoidal height, and the mean sea level is height from the geoid. These are two different things.
Sir, I think we use EGM file to accurate it, sir. EGM 08.
What do you mean by EGM 08? Can you explain it?
Oh. No, sir, I can't explain, but
From
I
where you came to know about EGM 08?
Sir, because sir, I worked in with the DGPS, sir. So I know something about that, sir.
Where you have worked with DGPS?
Sir, in Noida, Janak Positioning and Serving Systems Private Limited.
Which one? Sorry.
Janak Positioning and Serving Systems Private Limited.
What they do?
Sir, they sell the DGPS instrument, and I go and give the training to the purchasers. So how
Okay.
to operate the DGPS, sir.
Mm-hmm. Yeah, what you mentioned is a global geoid model. You understand?
Okay, sir.
What you explained just to us, EGM08, it is a global geoid model. Now, where to use those models? So in GPS, you have such kind of tools where, or field software where you insert the global geoid model which is available, and the moment you insert it, the ellipsoidal heights get converted to geoid height or orthometric height. That is a different thing. What I am asking is about the Google Earth, not GPS. Okay, anyways, so I mean, that is the point which I want to mention it here. So I'm just sharing the screen. That initially you have to be a little careful about what you are, you know, so in geodesy, you have this definition that geodesy is defined as a discipline that deals with the measurement and representation of the Earth, its gravity field and geodynamic phenomena in three-dimensional time-varying space. Okay. So obviously our objective is to this prime field where we have to understand about the Earth. So it, as it says, it's a discipline that deals with measurement and representation of the Earth, its gravity field. See, there are three aspects: the representation of Earth. So in representation, we'll have size and shape. It's and when I say size and shape, obviously the orientation is included. The orientation means its orientation in space. Okay. And then the geodynamic phenomena in three-dimensional space, time varying space, obviously, spatio-temporal understanding. So this is geodesy. Okay. The let me just use that. The basic problems of geodesy is the determination of precise global, regional, and local three-dimensional position, as I've told you, isn't it? In the initial discussion, our objective is to work at global level also, we work at a regional scale also, and we work at a global scale also. So just like what Shivam has told us, the EGM08 is a global geoid model. It is a global geoid model. Now the 2020 version is also available. ECM 20 is also available. We'll discuss in detail about this. The problems are very simple, that we have to determine the precise global, regional, and local three-dimensional position. We have to also determine the Earth's gravity field. We will discuss more about it. What do you mean by gravity field? Obviously, gravity is something which is a very inherent or very important characteristic of Earth. Then obviously measurement and modeling of your geodynamical phenomena. What is geodynamical phenomena? The earthquakes, the landslides, the subsidence, the volcanoes, the ice sheet movings. They are all geodynamical phenomena. Okay. Then this figure explains everything. This is a very good figure that explains everything. This is your Earth, let's say. This the lithosphere and the mantle and everything is opened up. So this is your Earth, and you have a geocentric coordinate system with your Z, Y, and X. Okay, and these are all associated phenomena which we have to explain. So one could also see that finding a reference frame, or to realize this geocentric coordinate system, we have to first think for a reference frame. The difference between reference system and reference frame is very simple. Your reference system would be your defined one, how you want to define a coordinate system. Just like, for example, the room where you are sitting in, probably the corner, the bottom corner where all three walls are joining, the floor, the other two walls are joining, that the intersection of that could be origin. One plane is xy, other is yz, and this is zx. This is your possible choice of origin, which you have realized it, isn't it? Just by looking at this figure, which I was telling in the bottom corner of your point, that you have realized this, the bottom corner, as origin. Similarly, one of our objective is to realize a geocentric origin and a three-dimensional coordinate system, just like that, which is centered at center of mass of Earth. Then you have x and y and z coinciding with the Earth rotation axis. But this is just our definition. The moment the difficulty arrives when we have to realize. Reference frame helps us in realizing this reference system, which is just explained to us, and obviously the associated earth science application. So if the moment we better define this xyz, and a team of scientists are working over it to better define this xyz, then only the applications which we are fascinated about, in geoinformatics, we are generally fascinated about variety of application: land use, land cover, glacier mapping, and the so-called urban change detection. So these kind of very fascinating application, but that can only be possible if you are having such kind of system in place. Now then you could determine the orbits. You can work on the volcano eruption. You can work with the and post seismic deformation after earthquake. You can work with crystal response to loading effects, and you can work with sea level variation. You can work with ice modeling. You can work with tectonic deformation and tectonic motion and deformation. Obviously, these are all challenging tasks which we have to perform, but the realization of the reference system is only the initial point of it. If you do not have a very stable reference system, all these applications will have a meaningful output. Okay. Obviously, the position, navigation, and applications are there. The navigation, surveying, precision agriculture, land and territory management, boundary dispute, cartography, cadastral survey. So all these are position and location based applications that have societal impact directly. Okay. So this this figure is explaining everything about the geodesy aspect. Now let us just focus on the examples. You could see that monitoring of solid earth, monitoring variation in the liquid earth, monitoring variation in Earth rotation, determining orbits for scientific satellites, monitoring the atmosphere with satellite geodetic techniques, monitoring the temporal variation in the gravity field of Earth, determining position and their changes with time. These all are part of your applications, which is we have just explained. This is the interior of Earth, where this is the crust where we are right now. We are here. This is the internal structure of it. We have lower mantle, liquid core, and then the solid inner core. Okay, so this is the whole interior of Earth. Which, but although we are more interested in the crust of it, where we are right now sitting. This figure explains the categorization of the different zonation, I would say, the crust, upper mantle, lower mantle, outer core, inner core, and you could see the scientifically how they are varying in nature. The upper mantle, part of the upper mantle, and the crust is lithosphere, and then you have a asthenosphere and then mesosphere. So this is general characterization most of you have seen in geography somewhere. And the crust is situated over a liquid belt. This is the liquid zone, which is that's why your crust, when it moves, it creates the earthquake. Okay, but ultimately our whole phenomena, I don't know what's the problem with this this time. This is very good representation of Earth, Sun, that you have this Earth, and you know that in your Earth you have satellites which are orbiting the Earth. You are observer at some place. Okay, this is your Sun. This is your Earth's orbit around the Sun. So these are the I mean terrestrial, celestial, and orbital coordinate system which we have to take care of. When we are working on solely on Earth, we do not know what is outside the Earth. We are working in terrestrial space. Okay, when we move out of the Earth and we have satellites in our orbit, then we are working in orbital system for satellites. And then when we move out so much that we have this such kind of picture in our mind that we have sun, we have stars in place, then we are working in a celestial kind of space. Celestial kind of space is there where we have sun, stars, they are all in picture. Okay, we have to work in celestial sphere. So that's a three dimension. Initially we work with terrestrial, then we have orbits, and then we have such system in place. So this is the initial introduction. Obviously, we have to go into the details of the three-dimensional space around us, but that is one objective, that you should have that much imagination with you, that yes, you can visualize those kind of things, because it is not possible to give explanation on about or not possible to present those figures which are very important to visualize those kind of hidden you know philosophies. Second is there is one in ancient Greek, there is one scientist called um, I just forgot the name. So what he did, he just at one place he just saw the sun which is just above the earth, and it has seen that in that well of that well, the rays of sun is just below to that water. There is no shadow. While in the at the same time, in he has observed that in during the same 12 noon, he has seen that there is another well where there is a shadow of sun is there. So he realized that there is something which could be utilized here. So he used the shadow angle try to find out the distance between these 2 points, and that originated the theory of geodesy, where he was the one who initially started this discussion just by looking at the sun shadow over to that well. So at one point he saw that there is no shadow in one well, and in other well there is a shadow on the walls. So he realized that this is happening because that we are considering the curvature of the earth. Okay, so that's how he initially, with the help of your arc and angle kind of principle, he realized and identified the distance between these two cities. And then with this little invention, the geodesy concept was evolved, and later on we are working in it.
Sir,
So with this
sir, his name is
little
Eratosthenes.
yes, Eratosthenes. I just forgot the name. Yeah, thank you. So this was the man who initiated this geodesy, and later on we are the one who are continuing it. In fact, you today are also part of it. So anyways, with this, we stop here, and we will continue from here. And I'll just post it out on the Teams, the requirement from your side in terms of understanding. So I'll give you certain assignment on the laboratory part, which you have to follow. And accordingly, we will discuss more on this. Okay. Any questions so far? Any questions? This is one time I am just again giving instruction to all the MTech students that you have to be very careful, since you have 5 courses running in this semester. You have to be very vigilant, and that's why I have told you, many of you, that you have to decide right now that what you want. You want a proper MTech, then you have to just devote your time towards your studies. It is not acceptable that whatever I'm giving to you, then you are not listening. There is no point in terms of discussion. Okay. As I've told you, MTech is all not about spoon feeding. I'll not tell you everything and each time that you have to do this, do this. You have to also responsible enough to do something on your own more than what is required. Okay. So this is expected. You do not expect that in MTech I would teach you like a 10th level student. Okay. It is expected that you follow what you are not aware of just by looking or going through the classroom, that okay, I am not aware about the basic calculus, I am not aware about the basic matrices, so I have to do it on my own. It is not like that I every time give assignment and then you do it. Okay, assignment is just a way of engaging you, and you have to engage yourself with the aspect which you do not know. Okay, so it is expected that you follow the instructions very carefully. If I ask you to watch the video, you should have watched it. Okay. Anyways, this first time you will realize later on, uh, and you will perform very well. And if you have any question, you can drop me a message. You can drop in chat box. You can drop me in personal message. I will be very happy to answer it. Okay. Anyways, that's it from
Sir,
today's class.
hello, sir.
Yes.
Sir, you have installed Boxbay.
Yeah, I'm listening.
Yes, sir. Sir, you have installed Boxbay in your Gmail.
But I often see that
No, sir.
also,
Sir,
so you don't worry
sir,
about that.
it asks to give my email access to it.
Why?
It is a spam app, Boxbay. So, sir, we cannot message you. That's why. Mail you.
Okay. So just drop me a message on your MS Team. Okay, I'll just uninstall it if by default it has installed. Okay.
Yes, sir. Yes, sir.
Okay. Thank you. That's it,
Thank you, sir.
students. We'll see you in the next class tomorrow. 3 p.m. Okay.
Thank you, sir.